Since its founding over 40 years ago, Ulano has become an industry leader for innovative products that place screen-printed images on an infinite variety of surfaces, shapes, and sizes. As part of an ongoing corporate commitment to provide helpful technical information to our customers, Ulano is pleased to present this step-by-step demonstration of one of its many stencil systems, the Ulano Direct Emulsion System. In this presentation, you'll see emulsion selection, screen preparation, stencil production, including the step wedge test for determining appropriate exposure, and stencil removal procedures. All Ulano products are manufactured to the highest standards and are formulated to enable you to make consistent, trouble-free stencils. In working with a direct emulsion, it's important to avoid contaminants during processing because dirt and debris, even air bubbles, can later affect stencil performance. What's more, in the absence of an automatic coating machine, the coating of direct emulsions requires considerable skill. You might even say that coating is an art developed through practice. A direct emulsion is a viscous, light-sensitive liquid that is physically coated layer upon layer into the screen fabric. When dry, the result is a light-sensitive screen that can be imaged to produce a stencil. And because direct emulsion stencils usually consist of multiple coats which completely encapsulate the fabric, they're capable of producing a great number of impressions from an individual screen, often as many as 100,000. Ulano has developed a wide variety of emulsion and sensitizer technologies in response to various applications and ink requirements. Basic differences in these emulsions lie in their printing properties, sensitizer components, ink and solvent resistance, exposure speed, and durability. In addition to the familiar diazo-sensitized emulsions, Ulano also manufactures diazo photopolymer, or dual-cure emulsions, which offer higher solids content, faster exposure times, superior imaging properties, and combined solvent and water resistance. Ulano's most technologically advanced group of emulsions utilize the still bosonium quaternary, or SBQ sensitizer. SBQ sensitized emulsions are pure photopolymer emulsions which are pre-sensitized and pre-mixed. They have an extended shelf life, an extraordinarily fast exposure speed, and are virtually unaffected by heat and humidity. To select the appropriate emulsion, consider the type of ink to be used, the particular printing application, and the type of light source that will be used. Ulano has made the task easier by compiling tables of ink types, printing applications, and light sources, and relating these variables to the appropriate emulsions. For instance, if you have a low-output light source, you should select a fast-exposing emulsion. But bear in mind that with diazo-sensitized emulsions, there is a delicate balance between the speed of the emulsion, resolution, and solvent resistance. Diazo photopolymer and SBQ emulsions offer the advantage of faster exposure speeds, while still maintaining high resolution, solvent and water-based ink resistance, and mechanical stability. For this demonstration, we will use Ulano 569 diazo emulsion. Before stencil production begins, there are some basic but important preliminary steps to consider. We look first at screen preparation and examine some of the major factors that affect the quality of the print. You'll first need to select a fabric that's right for the particular printing application. Keep in mind that the fabric you choose, not the thickness of the stencil, will be the prime determinant of the ink deposit thickness. In selecting a fabric for line work, to ensure an accurate print, measure the width of the finest line, positive or negative, to be printed, and select a fabric whose thread diameter is no more than 1/2 that width. If the thread diameter is greater than 1/2 of the line width, the results may not be acceptable. In considering halftone work, multiply the halftone line ruling by at least 4 to determine the minimum mesh count that is appropriate for the job. This will provide sufficient anchorage for the smallest halftone dots. In addition, it will minimize the effect of moire patterns. If the mesh count is too low, the stencil won't have enough threads to adhere to. And finally, consider fabric color in selecting the fabric. Dyed fabric improves fine detail reproduction because the dye in the thread reduces light undercutting, helping keep extremely fine details open. Dyed fabrics do, however, require increased exposure time. For this demonstration, we will use a 90T to 30T in the English system monofilament white fabric stretched over an aluminum frame recommended for improved multicolor registration work, since wood frames tend to swell and warp. Proper tensioning of the screen will assure good registration, help avoid premature breakdown of the stencil due to overflexing by the squeegee, and allow a more even emulsion deposit during coating. Follow the manufacturer's recommended tension for your particular fabric. In this demonstration, a stretch and glue frame will be used, but self-tensioning frames are a good alternative when mechanical or pneumatic equipment is unavailable. At this point, the fabric can be prepared to make it more receptive to the emulsion. This assures good stencil adhesion, thereby minimizing premature breakdowns. Synthetic fabrics, with the exception of Ulano mesh, should be abraded before use. This initial abrading step enhances adhesion. Start by wetting down the fabric with a thin sheet of water on the print side. Scrub on Ulano No. 2 microgrid. Work the microgrid around on the printing side of the fabric with a stiff bristle brush. Now rinse both sides with tap water. As you can see in these micro photographs, there's a considerable difference between the two fabrics. The example on the right has been properly abraded and is capable of a much better emulsion retention than the unabraded fabric on the left. As a final step before stencil making, all fabrics, metal, silk, synthetic, new or used, must be degreased to remove contaminants. Degreasing should be done just before coating to give dust and dirt as little time as possible to settle on the mesh. Apply Ulano No. 3's green degreaser liquid with a brush. Thoroughly degrease all areas within the frame, not just the area of the stencil, and degrease both the printing and the squeegee side. Leave the degreaser on for 1 or 2 minutes and rinse off completely. Ulano Gel 23, a combined roughener and degreaser, offers a convenient one-step method for preparing screens effectively, especially large screens. Brush Ulano Gel 23 vigorously on both sides of the wetted fabric. Let it stand for several minutes, and then rinse from both sides. Now that the screen is properly prepared and thoroughly dried, the screen can be coated with emulsion. With the exception of Ulano's SBQ pre-sensitized emulsions, all Ulano Direct Emulsions are supplied in the correct proportions as 2 basic components, a liquid emulsion and a sensitizer in either powder or syrup form. For this demonstration, we are using the powder sensitizer supplied with Ulano 569 diazo emulsion. First, add lukewarm or cool water up to the shoulder on the sensitizer bottle. Shake well, then check the liner of the bottle cap. Particles of undissolved diazo remaining on the white cap liner indicates that further mixing is required. Once completed, allow the solution to debubble for 15 minutes. Next, under yellow safe light, pour all of the dissolved sensitizer into the emulsion and stir with a clean, broad, flat plastic or stainless steel instrument until the emulsion is uniform in color. Don't use stirrers made of copper or iron. They'll react with the emulsion. Stir gently, taking care not to introduce air into the emulsion. Be sure to scrape the stirrer across the sides and bottom of the emulsion container so that all of the emulsion is mixed with the sensitizer. The emulsion has now been made light sensitive. Set the container aside with the cap loosely closed and wait at least 1 hour for the emulsion to debubble. When working with Ulano's diazo photopolymer or SBQ emulsions, remember that they are already light sensitive. These brightly colored emulsions should be handled under safe light conditions at all times before exposure. Diazo sensitized emulsion can be stored from 4 to 6 weeks at normal room temperature, or for up to 3 months if refrigerated, so it's good shop practice to record the mixing date on the container. Ulano's SBQ emulsions have an extended shelf life and don't require refrigeration. When the sensitized emulsion has fully debubbled, it's ready to be coated onto the screen. Direct emulsion can be difficult to control during coating, and considerable skill is required to coat evenly time after time. However, 2 devices make the process more controllable. First, a stand that holds the screen at a comfortable height and uniform angle will provide additional consistency during coating. And second, the coating apparatus should be a smooth-edged scoop coater. The scoop coater gives a more uniform amount of emulsion, layer after layer. Now let's look at 3 coating methods. In method number 1, 1 coat of emulsion is applied to the printing side, taking care to prevent excess emulsion at both ends of the stroke. Then 1 coat on the squeegee side, which pushes the emulsion back out to the printing side where it should be. This is the simplest, quickest coating method, but it permits only the poorest definition because the emulsion doesn't really stand away from the fabric. The weave of the fabric is evident in the stencil and ultimately in the print. In method 2, 2 coats, wet on wet, are applied to the printing side. The screen is rotated 180 degrees after each coat. Then 1 to 5 wet on wet coats are applied to the squeegee side. This method starts to build stencil height above the fabric and thus begins to achieve acceptable definition. To achieve higher definition, there is a 3rd coating method. Method number 3 derives from method 2. After complete horizontal drying, additional emulsion coats are added to the printing side of the screen. It's important to remember that although additional layers of emulsion improve print sharpness or definition, resolution and printability may both become problematic if too much emulsion is applied. Additional coatings are often not necessary when diazo photopolymer or SBQ emulsions are used. Their high solids content helps form a sharp stencil edge with fewer layers. Once the screen is coated, extra emulsion may be spread into the non-image areas to serve as a blockout. If your application calls for the use of water-based inks, block out with one of Ulano's water-resistant direct emulsions and expose along with the main image, or use a Ulano water-resistant blockout. Allow the emulsion to dry completely between each coat, preferably in a commercial drying unit such as this. Horizontal drying, printing side down, aids gravity in pulling the emulsion through the fabric. It builds a flatter layer on the printing side, independent of the fabric weave. Exposure is a critical step, and without proper exposure distance and exposure time, all the careful preparation could be wasted. The minimum exposure distance recommended for all light sources, except fluorescent tubes, is 1 1/2 times the diagonal measurement of the image. While it's true that the Ulano datasheets give theoretical base exposures, individual lamps, ambient conditions, and the thickness of the stencil are all variables that affect exposure time. There are several methods to determine what the right exposure time will be, but the most accurate method is the step wedge test. Later on in the program, we'll demonstrate how to conduct the Ulano's step wedge test procedure. Upon completion, the operator can be assured that future stencils will be exposed properly. Before making an exposure, take the time to clean both sides of the contact glass to cut down on the chances of pinholes. Good vacuum contact between stencil and positive is maintained using a soft blanket. Ulano emulsions require an exposure source rich in the long UV and visible blue part of the spectrum. Several types of light sources are available. Metal halide is best because its combination of wavelength and intensity produce a well-defined, sharp stencil in the shortest period of time. Mercury vapor and pulsed xenon light sources also perform well. Fluorescent tubes or quartz lamps are poor but serviceable alternatives for non-critical work, because the light they emit is more diffused and won't render a sharp image. At this point, the dry screen is exposed with the film positive for the correctly calculated amount of time. When the screen is removed, a latent image will be seen with the diazo and diazo photopolymer emulsions. As shown here, the emulsion has returned to a violet color because the sensitizer has been decomposed by the exposure process. Note that SBQ emulsions generally will not show a latent image after exposure. Now the screen is washed out with a hard spray of water, first from the squeegee side, then from the printing side, until the image areas open up. The thicker the stencil, the longer the washout time. If the stencil feels slimy or soft, it has not been thoroughly exposed. When washout is complete, rinse both sides of the screen with a gentler spray until all foam or bubbles are removed, finishing on the squeegee side. Dry the screen and frame thoroughly. Warm air, up to 40 degrees centigrade, 102 degrees Fahrenheit, or a fan will speed drying. The processing of Ulano emulsions is straightforward. However, it may be useful to take a closer look at how to determine the proper exposure time of the stencil. For this, Ulano recommends performing a step wedge test, a series of 5 incremental exposures, all made on the same stencil. The test uses a film positive designed with a wide variety of line thickness with Ruby Lith and Amber Lith brand masking films. Use the exposure time listed on the product datasheet to calculate the starting exposure time for the test. Place the coated screen with the positive taped on it in a vacuum frame and expose for 50% of the approximate exposure time for your light source. For the second exposure, tape the masking film in place so that it covers about 1/5 of the positive, and expose again, this time for 25% of the approximate exposure time. Move the mask so that it covers 2/5 of the positive, and expose again for 25% of the approximate exposure time. Continue to move the masking film over 3/5 of the positive and expose as in the last step. Now, covering 4/5 of the positive, the final exposure is made. Of course, the percentages of exposure can be varied as desired, but the end result will still be a stencil with the approximate exposure and 2 exposures above and below this approximate time. Process the stencil as before and dry. When the stencil is ready, make a print from it. After the print dries, compare it to the film positive. Usually the highest exposure consistent with the printed detail or resolution required gives the best edge definition and greatest wear characteristics. Fine line resolution requires special care to avoid overexposure. Remember that the resolution of your stencil is also dependent upon the coating method used, as discussed earlier. A thicker coat of emulsion on the printing side of the fabric improves printed edge sharpness or definition, but too much emulsion can also reduce resolution. The only definitive criteria for judging correct exposure is the printing performance of the stencil. Color change, particularly with SBQ emulsions, is at best an indirect indicator. During washout, the inside of the screen should be hard and free of sliminess. Ultimately, the step wedge test is valuable insurance against wasted time and materials. Now let's look at how to remove the stencil and reclaim the screen after printing. First, remove the ink as soon after printing as possible, with the solvent recommended by the ink manufacturer. Then degrease both sides of the screen with Ulano No. 3 screen degreaser to remove oily ink or solvent residues as much as possible. After degreasing, rinse the screen thoroughly with water. Water alone will remove Ulano's No. 10 and No. 60 screen fillers. Water-resistant blockouts can be removed along with the stencil by applying either Ulano No. 4 stencil remover liquid or Ulano No. 5 stencil remover paste with a brush on both sides of the screen. The screen should stand for no longer than 5 minutes, because if the stencil remover is allowed to dry, it may cause stencils to become permanent. Wash away the stencil with a strong pressure water spray, or even better, a commercial power spray unit. For industrial use, Ulano No. 78 haze remover paste used with a commercial power spray will remove ink haze and stencil scum. Diazo stains may be removed with Ulano No. 75 Diazo stain remover. Ulano wants you to achieve perfect stencils every time. That's why Ulano provides a wide range of highly consistent emulsions and sensitizers developed for your particular application, ink, and light source. Full information on the range of Ulano Direct Emulsions and their recommended applications is available in the Ulano Direct Emulsions booklet and in technical literature available from Ulano or your Ulano dealer. Ulano is also ready to support you with sample packets, with demonstrations at major trade shows, with a worldwide dealer network, and with a telephone information service for fast response to your needs. For additional product information about Ulano's high-quality stencil systems, contact your Ulano dealer or technical representative.